Good morning, ladies and gentlemen. Today we are going to be talking about angles and how to measure them with a protractor and how to draw them, and a few other terminologies to do with angles. So what's very important today is that you take very good notes, because there are a bunch of new definitions and you'll need to be able to remember all of those. And so every time I teach you a new word, I want you to write that down in your notes and keep that handy, so that when you answer the questions on today's lesson, you'll be able to reference that. So the first thing we're going to do is I'm going to give you one or two definitions that will lead us into angles and how to measure them. So the first thing we'll talk about is a line. Now, I know you know what a line is, but in maths it's got a very specific definition, and it is often the shortest distance between 2 points. So if I've got a point over here and a point over here, a line will be a straight line between those 2 points. And so a line is the shortest distance between 2 points. Now, pause the video, write that down in your notes, and make sure that you've got that. The next thing we're going to talk about is a ray. And a ray is very similar to a line, except that it extends from one point to infinity. And so we'll start off, if we wanted to draw a ray, it would be a point and then a line, and we would say an arrow at the end. We would draw an arrow at the end of a ray to show that it starts at this point and continues on forever. And in real life, we don't often get rays in our day-to-day workings. You don't often say, well, what's the length of this room? And oh yeah, the room extends off to infinity. But when we look at more complex information, sometimes we will use rays. So knowing these two things, we can now start talking about what an angle is. And anytime you have either two lines or two rays, or a line and a ray going from the same point, you will have an angle. And the way that we show an angle is just by drawing a small fraction of a circle in between those two rays. And it's important that you draw this in when you're working with angles, because if you ignore it, you're not sure what angle you're talking about, because there's an angle over here, but you could also find the angle over there. And so you actually really need to draw in your little angle sign in order to show the angle that you are talking about. So over here we have an angle. All right, and so let's make sure that we've got these definitions down. So a line, again, is the shortest distance between 2 points. An array is a line that extends from one point to infinity. And now we're going to talk about our angles. Now, an angle is a fraction of a circle. Okay? So if we had a circle over here, and we took that circle and we divided it into 360 pieces, you would end up with 360 degrees. All right? And so mathematicians, ages and ages and ages ago, when they were trying to figure out how to work with circles and things, they had to decide on what size they would break up a circle into. And they decided to make a circle into 360 pieces because having more pieces makes it more accurate. So you wouldn't want a circle and say, well, I'm going to divide it into 4 degrees, because each degree would then be a quarter of a circle. And it would be kind of useless, because then you'd have to find fractions of a quarter, and quarters are difficult to divide. So they thought, well, I need to come up with a number that is really, really easy to divide, because if I need to work with fractions of a circle, then I need to be able to divide those different angles up. And so after much research, they found that 360 is a number that is very easily divisible by all numbers under 10. It's not divisible by 7 as far as I'm aware, but I think it's divisible by 10, it's divisible by 9, I think it's divisible by 8 and 6 and 5 and 4 and 3 and 2. So it means that it's very easily divisible, and it means that it's a really easy number to work with. So the mathematicians, when they first came up with this way of dividing a circle up into degrees, they chose the number 360, and that's why we work with circles that are split up into 360 degrees. So if I have my circle over here divided into 360 degrees, each one of those little angles is 1 degree. So if you add up a bunch of those degrees, you might have 10 degrees or 45 degrees or 90 degrees. And the more you add, the more degrees you have. And if you have 360 degrees, that makes a full circle. 360 degrees is a full circle. And if you're into any sort of extreme sports like snowboarding or skateboarding or skiing, wakeboarding, all of those kind of things, you'll know all about a 360, because in those moves it involves like jumping into the air usually and making a full turn, so that if you were facing this way, you spin all the way around and end up facing the same degree. So if you were there, you spin all the way around and you point back there. You've turned 360 degrees, and that's from our maths. So if you are going to measure an angle, you need one of these. It's called a protractor. And these are really, really helpful when we want to measure or draw angles. And the way that these work is you can measure an angle from this side, or you can measure an angle from this side. And if you're measuring from the right-hand side, you start on the inside because that's where 0 is. And if you're measuring from the left-hand side, you start on the outer ring because that's where 0 is. And it shouldn't be something that we need to memorize. You just need to think, okay, I'm going to measure this angle, and you can line up your protractor however you want to, as long as you make sure that you're counting up from 0. If you're counting up, or if you're counting down from 180, and you start with your line on 180 and you end up at 120, your angle isn't 120 because you didn't start at 0. Your angle would actually be 180 minus 120, which would be 60. Which, if you look at where 60 is, it's right in line with 120. So we'll talk about how to use one of these really, but the first thing you need to notice is that there's an inside set of angles and there's an outside set of angles. The outside set of angles is if you're measuring from the left-hand side up, and the inside set of angles is if you're measuring from the right-hand side up. Okay, so if we wanted to measure an angle, we would always have the angle that we want to measure. And the trick is, on your protractor, you'll have a circle in the middle, usually sometimes a little dot, and you always want to make sure that that little dot is on the point where the two lines or the two rays or the line and the ray meet. This point is called the vertex. The vertex is where the two lines or the two rays meet, and that is where you put the circle. And then the next thing you need to do is you need to make sure that your 0 lines up perfectly on the line. Alright, because I'm measuring on this side, on my right hand side, it means I need to use the inside angle of my protractor. Alright, because I'm starting at 0. Alright, and then I'm going to look up and I'm going to go and see where the other line meets on my protractor. Over here, it is exactly 50 degrees, which means that this angle over here is equal to 50 degrees. All right, if we tried another example where we had an angle facing the opposite direction. Now when I put my circle on the vertex and I line up the 0, if I was to go from this side, because I'm calculating the angle on the left hand side, I need to use the outside ring because that's where my 0 is. So you always look for the 0. And if I count up from here, I can see that that point lines up with my 45 degrees. So this angle is equal to 45 degrees. Now, that's how to read how big an angle is using a protractor, but we can also draw an angle using a protractor. So if I said to you, hey, I need you to draw me an angle that is 75 degrees, what you would do is you would start off with a point and you would place your circle right on that, and that point is going to be where your vertex is. The next thing you're going to do is you're going to draw another point exactly where the 0 would be, and you're going to keep your protractor in exactly the same space, and you're going to put another point exactly where 75 degrees would be. And you notice that because I'm looking on my right hand side of the protractor, I'm using the inside circle to find the amount of degrees. So I've got my 2 points. All I need to do now is collect those up. And over here, this angle is now 75 degrees. Now, you should be able to use a protractor to identify what angles are and also to draw your own angles. All right. Now, the next thing we need to talk about is the different types of angles that we get. And all of these angles are what we would call acute angles. Okay? And acute angles, please write this down. Acute angles are all angles that are greater than 0 degrees but less than 90 degrees. So acute angles are greater than 0 degrees and less than 90 degrees. All right. So the way that I always remember that is because these are the smaller angles, and I spelled this wrong. Acute angles, because these are the smallest ones, they are quite cute. And so we remember that those are acute angles. And the next thing we're going to talk about are right angles. Right angles are exactly 90 degrees. So they are equal to and these are really the big deal when we start talking about angles, because we find them everywhere. A right angle, if we look at it like this and we draw it, we put our vertex over here, I find 0 and I find 90. And if I draw that, a right angle makes a perfectly perpendicular joining of the lines. And we show a right angle by drawing a little square in the corner there. If you've got a little square there, it means that it is 90 degrees. It is a right angle. And I mean, we use right angles all the time in our natural world, well, in the built world, because in all of our buildings we've got right angles. Every corner of a room, well, most corners of rooms are right angles. Buildings are all built at right angles. Car axles meet tires at right angles. There's a huge amount of physics involved with right angles. Your car's motor works off of pistons pumping at right angles to certain other angles. So this is a really important angle that we've really experienced in the real world. And so if you ever see a perfect corner with a little box in it, that means that it's a right angle. If you measure a right angle, you must always make sure that instead of doing the little circular angle sign, that you put a square angle sign. All right, and then the last one that we're going to talk about for now is obtuse angles. All right, so if we've covered on our protractor 0 to 90, at 90, what else do we need to cover? Well, we need to cover 90 to 180. So obtuse angles are greater than 90 degrees and less than 180 degrees. So what this protractor is really doing is, if we start at 0, it just counts the amount of degrees that we've got in our angle. And so each of these tiny little marks along the outside of the protractor, that is exactly where each degree would be. If you added all of them up, there would be 360 of them in a full circle. Protractors are only half circles, so we only deal with half of the 180 degrees. Half of the 360 degrees, which is 180 degrees. So, I mean, if we had angles that were bigger than this, which you can do, if I had an angle that looked like that, 180 would be a straight line. And so we've got 180 plus whatever angle this is. We call those reflex angles, but we're not going to worry too much about that for now. And the reflex angles will go all the way up to 360 degrees. And then we'd have a full circle, and then we could start again. So for now, we just need to know what each of these things are, and we need to be able to identify angles that are acute angles, right angles, obtuse angles. We need to be able to draw our own angles using a protractor, and we need to be able to measure angles using a protractor. Okay, so the last thing we need to talk about is the two different types of lines we get. The first one is a situation when you have two lines running next to each other, but when they will never ever meet. So, like we were talking about now, if you've got two lines that are kind of running alongside, or two rays, and they keep going, they will come to a point where they'll meet, that will form a vertex, and they will make an angle. But we do get situations where we have two lines running next to each other, but they're exactly the same angle, so they never end up meeting. And two lines like this we call parallel lines. All right? I'm worried about the spelling here. So parallel lines are two lines that run next to each other and never meet. And we see these a lot also in the shapes that we deal with. If we look at a rectangle, the opposite sides of the rectangle are parallel to one another. And so the width of this rectangle would be parallel and the lengths of this rectangle would be parallel. If we extended these on to infinity, there would never ever be a time where they met. All right? And the other thing that we're going to talk about is perpendicular lines. And you might have heard me mention it when I talked about right angles. But perpendicular lines, please excuse my spelling. I haven't written these words out in a long time. I'm not sure if they're correct. But perpendicular means that 2 points meet at a right angle. So, well, two lines meet at a right angle. Two lines meet at a right angle. And if we go back and we look at this rectangle that we drew earlier to show the parallel lines, the length and width are perpendicular, which means that the length and width meet at right angles, but the length and length will run perpendicular. The two lengths run perpendicular, but the two lengths run parallel to one another, and the two widths run parallel to one another, but the length and the width are perpendicular to one another, and they make a perfect 90-degree angle. So if you were on a football field and you were running down the one wing and your teammate was running down the other wing, and you kept running for the rest of your lives, you should never ever meet and bump into one another, no matter what, provided you keep running in a perfectly straight line. But if you had your buddy running down the width of the field and you were running down the length, you would meet and you would be running perpendicular to one another. So another important thing is that we need to talk about how we show this. So if you have two lines that are perpendicular, you can mark them by putting a line through. All right? If you've got two sets of lines, like in a rectangle, where the lengths are parallel, yes, you can put one line, and the widths are also parallel, so you could mark it with two lines. Okay? Just to show that these two sides are parallel and these two sides are parallel. And yeah, that's about it. Please make sure that you have written down each of the definitions and that you understand what each of those definitions means. We've covered lines, rays, angles, parallel lines, perpendicular lines, acute angles, obtuse angles, and right angles. And that's all we really need to know for today's lesson. But the main part of today's lesson is that we remember how to use a protractor. I've included in your assignment for today a few links that will give you further description and show you more examples on how to use a protractor. So if you didn't quite catch what I was explaining here, there's some more information further on in the assignment. So good luck. I hope you guys do really well. I hope you understood this, and have a great day. Bye.